Robotik in der Industrie. Der Podcast mit Helmut Schmidt und Robert Weber. Hello everybody and welcome to a new episode of our podcast. My name is Robert Weber and I'm sitting in Copenhagen at Europe's, and I invited today one guest, and it's Nick from BizLink. Nick, welcome to the podcast.
Thank you very much, Robert. I appreciate the invite. I'm really looking forward to a conversation today.
Yeah, me too. So Nick, before we start talking about BizLink, please introduce yourself briefly to the listeners.
Yeah, sure. So I'm Nick Tebeau. I'm the Global Director of Product Management Innovation at BizLink Robotic Solutions. My background is in industrial automation my entire career, different robotics and machine vision and control solutions to what I'm doing today.
Share a little bit with our listeners, what is BizLink? What is BizLink doing?
Yeah. So, BizLink is a pretty large corporation, which is most notably in cable systems. But for our business unit, Robotic Solutions, we have been for over 20 years a major player, one of the largest one in cable management solutions for industrial robotics, mostly in the automotive manufacturing space, but not only limited to that.
How difficult is the cable business?
The cable business itself is quite a difficult business in terms of, let's say, differentiating yourself in the marketplace. How we've succeeded in our business unit is because a lot of the high flex cables, that is our background and how we got started into industrial automation, is creating in the early days of industrial robots the most high flex cables. And then we started getting involved with companies in Germany and France who had figured out how to create more complex cable management solutions specifically adapted for industrial robots, which then made the cables last longer. So in essence, the success of cable management helped proliferate the use of industrial robotics because they didn't break down so often.
Okay. And now you combine cables with AI. What are you doing with AI, or let's call it machine learning, right?
Sure. So, as I said before, we have this history of more than 20 years in cable management solutions. We are working with most every automotive manufacturer and tier one supplier worldwide. So we have hundreds of thousands of cable management solutions installed around the world. And what we learn over time, of course, is what causes these cable management systems to still wear and break down over time. And as is typical in all automotive manufacturing, downtime's expensive. And if your robot is not performing well. So what we found is how to monitor our cable management solution itself to be able to detect when the corrugated tube, which is the protective layer around cables and hoses, breaks. And this is a leading indicator that you're going to have cables break soon, whether that's in the next minutes, hours, days, it's soon.
Mm-hmm. Is it a time series model then next to the cable, or can you describe a little bit what you do technically?
Yeah, I can describe a bit. So we have retract systems. We have one that's called an LSH3 and another one called the LSH Delta. And these have a mechanical compliance that allows about 350 millimeters of compliance as a robot needs additional cable at the end of arm tool. And so what we have developed with CareDP is an edge device which is then monitoring this motion back and forth.
But this is also interesting for the robotics or for the companies, for your customers, right?
It's very interesting, both from the OEM perspective and also with robot manufacturers. And so with all industrial AI, what is always a big question mark and what we try to approach this problem with is how to reduce the complexity of integration and how to make the application be as fast as possible ready to go. So our solution doesn't actually connect to a robot. We're not connected to the robot controller. We're not connected to a PLC. We are just connected to our cable management, what we call a dress pack for the mechanical compliance. And we're monitoring that motion back and forth.
Okay.
So there's a correlating factor with the motion back and forth of a dress pack system. But of course, it is not actually monitoring the true motion of a robot. So we have with AI been able to figure out how to monitor the cable management solution to be able to detect problems or deviations within the robot motion and the corrugated tube.
Mm-hmm. But do we talk about time series data? What kind of data is that?
It's time series data. I mean, we are monitoring the motion itself, which of course then is creating time series data.
So it must be a very small model, or am I wrong? Because it's running on the edge.
Actually, it's not a small model. And the reason for it is that every robot is completely different. And so there is no one model that is going to just work out of the box. And so how it works within CareDP is that after this system is live on a robot, it is actually figuring out the new motion parameters of that robot. Again, we don't actually know the true motion of the robot. We only know it through our dress pack. And the AI itself is developing its own model over time.
So it's in context learning.
It's in context learning. And there are many elements to it, just so you can imagine, is that when you have a corrugated tube that is having a full package of weld equipment and hoses for water, then you have a much different type of break of a corrugated tube than you do if you only have two cables inside. And so the motion can change. And this over time is all feeding back into the algorithm, as well as how many different motion types. So some robots have 3-5 spot welds, and that's all it does. And some robots are having very complex series of motions. And again, we don't know this information going on. So the model itself is figuring out over 5 to 10, let's call it working days, of how many variations exist, how much motion exists on the dress pack, and is figuring out its own best strength model to apply for the future.
So from my point of view, you also need a state tracking, because you need to know where's the robot arm in which state, and then to collect the data. Or am I wrong?
Yeah, we don't connect to the robot in that way. Again, we're not connected to any device in the plant equipment. And so from that, it is establishing what is normal, if you will, after that 5 to 10 days. And from there, it is going through each cycle of motion and doing a comparison check. I'm oversimplifying when I say comparison check, but I like to say to people, in the old iPhones, you used to program your thumb fingerprint, and you have to do it many, many times before the phone says, hey, I like this. I understand now that that's your unique fingerprint. And then in the future, it's able to tell whether there's a deviation from that or it's accepted. That's kind of a similar approach to this.
So one step back, we are talking about classification tasks, or is there also a forecast, and you do classification on the forecast that you can see, oh, it will break in 1 hour, or our forecast tells us it will break in 2 days or in 1 day? Or do you only do a classification on the status quo?
Yeah, so where we're at today is that we're classifying the status. We're not forecasting. And it still brings the value when you think about.
But is it an option to do that?
Not yet.
Okay.
Not yet. It's something that we see as a possibility in the future, but there are complications to that. And where we see is that even today, when you think about the practicality of the application, the predicting whether a corrugated tube breaks in a few hours doesn't change the fact that you still have some time after the corrugated tube breaks. It's not that a corrugated tube breaks and you have a downtime event on the robot itself. So our focus was on having the best reliability and trust factor to the actual status of the corrugated tube, and not reduce our percentage of trust by trying to create a forecasting model on top of it.
Mm-hmm, mm-hmm. What do customers say?
Customers are happy to have the status. And when you pair it with practical tools like email alerts, apps on your cell phone, dashboards where they can actually use it similar to like a CMMS system where you can actually kind of tag some of your different problems and create trend lines across your plant. This is creating the practical value that they're looking for.
Mhm. Is it constantly doing a classification task, or do you have to give them a signal, do now a classification task, or is it hourly? Is it weekly, daily? What is the idea there?
So there is an initial self-learning mode, and after it goes live, then it is in a constant state of, let's say, judgment and looking at whether or not it needs to update classifications. Again, this is all on its own. And why that happens is also because corrugated tubes are polymers, and polymers age and they elongate. And this, of course, could take away from the percentage of reliability to a model if it was a static model. So then over time, it is also learning the age of the corrugated tube and adjusting itself accordingly.
Mm-hmm. Okay, that's really interesting. I want to come back to the edge device you mentioned. So, do we talk there about, I don't know, an Intel Atom, or is it a GPU, or what kind of hardware do you need for that?
Yeah, I would say here that we have provided our hardware for the customer, and so all inside of there is it's a small onboard computer.
It's a CPU.
Yes, CPU. And so it's all in one unit. And so we made it simple for retrofitting as well so that the customer can go right away, even on existing systems. And then it's cloud connected.
Okay. Is that a problem for your customers?
Actually, I would say that it's mixed. I would say for the majority of customers, it's not. And the reason why is I won't name drop, but one of the customers said, if someone in theory were able to hack into your system, what would they know about our operations? And the answer is nothing. What could they control about our operations? And the answer is nothing, because we're not connected to any of the plant equipment. And this, for most IT groups within automotive, is an easy pass. This is one of the benefits to the approach we have taken with the product.
Absolutely, absolutely. And you have no connection to the PLC or something like this. You have no safety critical topics there, right?
Correct.
Yeah.
And we're backed by Microsoft Azure, who we use to partner for IT security.
Sure. Let's look a little bit into the future. There could be more things to do with these time series data. Or am I wrong? Do you have some fantasy what's also possible to do with that?
Sure. There is many options that we can predict into the future, but probably one of the biggest ones is understanding the changes of the robot programs. We're already seeing today that we're able to detect when someone has gone into a robot and changed the robot program, which is a big deal in manufacturing because once that line is up and running, in theory, no one should change the robot program at all. And when they do, what does that create? Major quality issues. So this is something that we're already able to detect, but we can see that in time, the ability to cross-link results from throughout a whole facility to understand where they might have bigger issues.
That's interesting, right? So it's not about one cable now, it's all about robotics fleet at the end.
Correct. And so these are discussions we're already having with some early customers. We've been working with customers now for approximately 2 years as we did pilots prior to our launch so that we could both prove out the technology and utilize that customer feedback to make a better overall solution for the marketplace.
Mm-hmm. Can you tell me two figures about the ROI of the edge device and your intelligent with the cable? How long is the ROI for this application?
Sure. So we're seeing for most cases less than 1 year.
Mm-hmm. Less than 1 year. Okay.
Less than 1 year. Yeah. We worked very hard to reduce the initial investment into these devices. And with that, the cost of downtime, of course, is variable throughout plants. You know, sometimes you read a McKinsey study and it says, okay, all downtime is 30,000 euro a minute. But the reality is that it's complex within automotive plants. Some lines, your final line assembly, of course, is quite high. but you go to sub-assemblies and it goes low. And even within tier one manufacturing, we've been able to show less than 1 year ROI, even with their lower value, let's say per downtime cost. And that's been our approach to the market.
Okay. So your main or your first customers are coming from the automotive industry, right?
That's correct.
Okay. So they are running this technology on different robots and different cells on their shop floor, right?
That's correct. We are robot brand agnostic. And so we also are able to serve multiple different types of applications within the plant.
Mm-hmm. So what is the next step when it comes to your AI solution? You already mentioned some plans, but can share some outlook? What is on the horizon when it comes to, let's say, cable, a typical hardware topic, and AI? How to combine these worlds? Do you have some more plans to share?
Yeah, it's always been the challenge in the industry. Many companies have looked into how to create smarter cables. And, so this is an area that we have looked at for years. It's not an easy solution, both from the technology and AI to predict the failures that you have, both in the shielding and other complexities of pairs, but also how to make it a, let's say, cost value solution for a customer. If you're monitoring every single cable within a solution, then how do you have that hardware and platform set up in a way that makes it low cost to install and low cost to maintain? I would say that this is where a lot of players and we've looked at in the past, and I could imagine in the future looking in these directions, but I think we're time away.
Nick, it was really a pleasure because this is a really nice application on-prem with a really nice approach. Can you tell me what is on your desk just before Christmas? What do you have to do?
Oh, it's always planning for the next year. We have a lot of projects with regards to this product that we are working with customers at, and as always, it's reflecting upon.
What is the biggest bottleneck when it comes to this solution? Is it to emphasize the customers to do that, or what is the biggest bottleneck?
I think whenever you have newer technology, then you're always doing a bit of educating as well as building trust with pilots and allowing them to get a hands-on feel. And in this way, this is where we find ourselves today. We always speak about the speed of adoption for new technology. And of course, we have some customers who are having an immediate response saying, yes, let's go now. And of course, others, you need more time to check all the boxes with IT security, check all the boxes to implementation.
But this is easy, right? So there's no connection to the shop floor.
That's correct. Let's say that it's, in most cases, fairly easy.
Mm-hmm, mm-hmm. Nick, it was a pleasure. Thank you very much for the insights into your approach, and bye-bye.
Thanks a lot, Robert. Bye-bye. Thank you.